talking about RSpec, assuming you know nothing about it, or even about what RSpec does. Oh, there it goes. Okay. So what is RSpec? RSpec is a TDD tool for Ruby. So what's TDD? TDD stands for test-driven development. The gentleman pictured here is Ken Beck. He is probably most responsible for bringing test-driven development to the software development community as a whole. He didn't invent it. If you ask him, he'd say he rediscovered it in the 90s. So test-driven development is it's a development technique. A lot of people get confused and think it's a testing technique. It's not a testing technique. It is a development technique driven by testing. And the idea is you write the test first. So why would you want to do that? So when you write the test, so there's a lot of advantages. When you write the test first, your code is testable from the beginning, naturally, because it has to be, because you wrote the test before you wrote the code. It ensures that your tests actually work, because when you write the test first, you have a failing test, and then you see it actually pass when you write the code. It has you focus on what before how, because you start thinking about how to test the code, and then think about actually how to implement it. So it's a shift that helps you design clean code better. And you get consistent test coverage because you're writing the test first. So if you're following this practice correctly, you don't ever have code that you didn't have a test for, so you've got good test coverage in all your code, which enables refactoring, which is a huge benefit. We like refactoring here. If you haven't, if you couldn't tell by the fact that Brian's done what, about 4 presentations now on refactoring.
Well.
So the refactoring is where you take your existing code and make it better. It's important because you will make a mess with your code. You have to know how to clean it up. And refactoring is how you do that. And you need to have good test coverage so that you don't break your code when you're trying to clean it up. And finally, one of the benefits that I've seen with test-driven development is I spend a lot less time debugging. I don't see this benefit actually mentioned a lot, but when I think back to before I started doing test-driven development, I probably, like 60% of my time was actually spent debugging, and maybe 40% actually writing code. And since I started doing TDD, that's completely changed because you have a whole test suite that tells you right where the problem is. You don't have to spend a whole bunch of time trying to find the bug. So the way TDD works is there's a cycle. Red, green, refactor. Just red, green, refactor over and over again. Like drill this, burn this into your mind. First step is you write a test, and then you watch it fail. You'll get to the point where you love seeing your test fail. You know it's working. You know the test is working. You know that you wrote the test right. Then you write the code to make the test pass, and you celebrate. Do your fist pump or your happy dance or whatever you do. And step 3, refactor. Oh yeah, this is what I did.
Yeah, that's easy.
Step 3, refactor. This is an important step. It's probably the one that most people leave out, but it's very important because you need to make your code beautiful. You need to keep it clean. And don't forget to refactor your tests as well. Your tests need to be clean and readable too. And then repeat. Do this over and over again, and your code just keeps getting better and better, and more features, and eventually you get to a point where you can release something and keep doing the cycle it never stops until you get tired of the code you're working on. So what makes up a TDD tool? Well, there's 3 parts that it needs to have. It needs to have a library for writing automated tests. Basically a library for expressing expectations in a way that it can test them. It needs a framework for organizing those tests into a test suite. And finally, you need a way to run those tests. So at a minimum, a TDD tool needs to have these, and RSpec does. So RSpec is not the only TDD tool out there for Ruby. There are several. There's test unit, mini test, and addition to RSpec, and there's some others, Cucumber. So why RSpec? Well, for one thing, RSpec is really organized around focusing on expected behavior. The guys that came up with RSpec found that a lot of people were doing test-driven development, not necessarily the best way. They were focusing on testing implementation details instead of testing the behavior. So their idea was to actually change the name to behavior-driven development and invent this tool that sort of linguistically tries to focus you on the behavior instead of just testing. RSpec specifications are executable documentation. This is actually a really good benefit of RSpec. You end up with if you do it right, you end up with a document specifying how your code, or specifying what your code does, that actually you can execute to see if it's true. This is actually, any test-driven development, you should actually write your tests so that they tell a story about what the code you're testing is supposed to do, but RSpec makes it really easy to do that in a very readable, sort of English-like way. Provides a rich set of tools for organizing your test cases. This is one of the things that I initially liked a lot about RSpec, was it made it really have a lot of flexibility in how you structure your tests, so you can fit your tests, the structure of your tests, to the shape of the code you're testing instead of to the shape of the framework, the testing framework. And RSpec is currently very popular. This is actually pretty important, maybe even the most important thing on that list. A lot of people use RSpec, so if you're looking at other people's code and reading the tests to figure out what the code does, it helps to be able to read it, so it helps to be familiar with RSpec. So, how do you get started using RSpec? Well, first of all, you have to install the RSpec gem. If you're using Rails, you want to use the RSpec Rails gem. Just throw it in your gem file, usually in the development group. If you're outside of Rails, you just use the RSpec gem, and then of course bundle, and you'll see some output, something like this. This is actually for outside of Rails. You'll notice there's actually several different RSpec gems. The RSpec gem itself, all it does is actually pull in the other gems. They broke it out into various pieces. So then once you've installed the gem, you need to set up your project to use RSpec. Particularly if you're using Rails, this is important, because Rails is already set up for testing, but not by default for testing using RSpec. So the RSpec Rails gem gives you this generator that you can run, and it sort of rejiggers your Rails project to use RSpec instead of test unit or whatever it's in. If you're not in a Rails project, there's RSpec has an initial, you can just run RSpec -- init, and it will give you some initial setup. It's not as important. You can do without that, but it's helpful. In both cases, you get this spec helper. You get a spec directory and a file called spec helper. This is the one that you get from the RSpec --init command. The one you get from Rails has everything that this does plus a bunch of Rails specific stuff. One important thing to note is this config ordering was random. What that does is it actually every time you run your tests, it runs them in a different order. That helps to make sure you don't accidentally write tests that depend on the order that they're run. Each test should be isolated from every other so that the order doesn't matter. So that will drive that out if you accidentally do it. All right, so specifications. RSpec focuses on tests as executable specifications. It's one of the distinguishing features of RSpec. They don't call them tests, they call them specifications. And the specification is it's just a description of the behavior that you expect the thing that you're specifying to have. You write those as executable examples. You write a bunch of examples. It should do this, it should do this. Then those examples are executed in a controlled context. It's very important. All testing frameworks give you this. It's very important to run your tests in a controlled context so that it's always, the test always runs in the same context. You know what that context is, which I'll be a little clearer later. So So we're going to start with the example we're going to use is a real simple example, just a stack. Just in case you don't know what a stack is, it's a data structure where you push values onto the top of the stack and then you pop them off of the top of the stack. So the last thing you pushed onto the stack ends up being the first thing that you pop off. And we're going to define just a simple interface. We'll have an initializer, have it take a values parameter in case we want to initialize a stack with already having some values, defaults to empty, and then we want to be able to push a value onto the stack, pop a value off of the stack, and then sometimes it's useful to be able to check the size to see how many values are currently on the stack. So we'll start with a very minimal specification. And just so you don't get confused, this specification doesn't actually test anything yet. It's basically empty. So usually the required spec helper is almost always the first line in your spec. It pulls in that spec helper file. Then you need to require the code that you're actually testing, and then the describe actually opens up the specification. Remember I said the specification describes expected behavior, and it actually does that using the word describe. So you say describe, you say what you're describing. Normally you'd start with a class, but this can actually be a string. And then you have examples of what the thing you're describing should do. And like I said, this doesn't. These examples are empty. They're actually just they're just the header of the example. They don't have a body, so they're actually pending examples. But already you can run this if you use the format documentation option for RSpec. You can run it, and you already get some documentation about what your code should be doing. You see stack pushes the value onto itself, and then stack pops the last value that was pushed. And it tells you that these are pending at this point. So let's go ahead and add some expected behavior. You do this with expectations. So in both of these examples, we create a stack, we do some stuff to it, and then we expect something. So you expect some value to match some other value. So and here is the matcher. So in this case, we're expecting something to equal something else. The EQ is the matcher you'll most often use. You can do probably 95% of your testing with just that one matcher. So we're expecting, if we push a value onto the stack, we expect the stack size to equal 1. And if we push 2 values onto the stack, we expect the value that we pop off of the stack to equal the last value we pushed on. So when you run this, if your code works, if it passes, you get an output that looks something like this. You actually just see the documentation of what your code should do, and it just says it works. Yes?
In which spec are you to go? This one, the model, the thing closest to what they would have.
In this example, I'm not inside of a Rails app. It's just I'm just developing some code, so it can go wherever. Yeah.
Probably on a lib directory. In this one.
Yes. Yeah. If you're working outside of a Rails app, normally you have a lib directory, a spec directory, and the structure inside your lib directory and your spec directory would match. So yeah. Okay. Good question. All right. So this is what it looks like when everything is hunky-dory. But what if one of your tests fails? This is one of the cool things about RSpec. It gives you a lot of output about what went wrong. So we see the actual example that failed. It tells us the exact expectation that was not met. And then it shows us what we expected and what we actually got. So that's very useful. That's actually in my opinion, one of the biggest advantages of the sometimes maligned DSL of RSpec is that in addition to communicating to the reader exactly what you expect, it communicates to RSpec exactly what you expect. So when something goes wrong, it can tell you exactly what went wrong. Okay. So matchers are how you check things. We already saw the EQ matcher. That just expects two things are equal. In this case, this will pass if S equals food, the string food. There's also a matcher called B. This tests for identity. So this expectation would pass only if foo and bar are actually the same identical object. And then you have matchers for numeric comparisons, less than or equal to, greater than or equal to. Should be obvious what those do. And then finally, sometimes you're dealing with floating point values, and floating points are inexact. They you can divide. I don't know. This is probably a bad example, but you might do some division. It should equal exactly 3. Mathematically, it should equal exactly 3, and you get like 2.999999997. So you need to be able to actually just check that it's within the margin of error. So this is a matcher that lets you do that. Otherwise, you could have tests that are failing inexplicably. All right. So one of the cool things that RSpec lets you do to organize your tests a little bit better is you can nest these describe blocks. This right here is a common idiom. It's considered a best practice actually to you describe your class first, and then nested under that you have a describe for each method that you're testing. And then when you and then the output looks like this. So you have your documentation output looks like this. You've got the stack, and then you've got the class, and you've got each method, and the tests are organized by the method that they're testing. This also helps you focus on, you should only be testing one method at a time. This helps you focus on that. All right, so this test could use a little bit of refactoring, which we all love. In particular, we see this, we're creating this stack. This line is exactly the same in both examples, and that's something you're going to be doing in almost every example, is creating an instance of the thing that you're testing, which RSpec refers to as your subject. So it gives you a thing called subject to let you create that in one place. So you have the subject. It's just a method to create a subject, and then you can give it a name. You don't have to give it a name. You can actually leave off the name, and it'll just be called subject. But that's generally considered a bad practice. You should give it a name, and then you give it a block with what you want it to be.
You lost one screen there.
Okay. But don't worry about it. The camera's on that screen.
Exactly.
Uh-oh. Getting better now. We're both done.
Perfect.
One guy's that cat.
One second. Okay. So yeah, so subject, give it a name, what you want it to be, and then down in your example, you can just refer to that by the name. And it actually, the first time you refer to it in your example, it actually goes and executes that block and creates the value. And it only creates it once for each example. Another thing that RSpec gives you is let. Let is very similar to subject. It's for creating all of the things other than the actual subject. In fact, subject is more like just a special form of let. So you have your main thing that you're testing. You might have other pieces that you need to create the thing that you're testing, and you use let for that. So like a subject, you just say let, you give it a name, and then what you want it to be. And so down, and then you can refer to it somewhere else. And down here, when we refer to stack, it goes up to our subject and executes that block to create the stack, and that block refers to initial values, and then it goes and finds the let and executes that to create those initial values. Another feature that gives you is nested context. And actually, I already showed you this because nested describe is already a nested context. Context and describe are actually the same thing. They're just two different names because depending on whether you're actually describing something or just saying, setting up some context for something you're already describing. So in this case, we create a context for when the stack is empty, when the size should be 0. And then down here we have our let with our initial values to indicate an empty stack. And then when you run with nested context, it organizes your output by this context. In this case, this is actually showing another context called after pushing two values, which you didn't see on the slide because you don't want to fit so much code on the slide. And then finally, you need to probably know about before. So the before block executes, before block within a context executes that block of code before each example in the context. So in this case, you need to do, a lot of times you need to do that you need to actually take some steps to set up your context. So in this case, we're defining this after pushing two values by adding a before block in which we push two values. And that's about it for this presentation. I'm just going to mention some other features that RSpec has. You have more hooks. So before was a hook. It was actually short for before each. You also have after each, which I've never used after ever. But you have before all and after all, and I think you have before suite, after suite, or something like that. There's 3 sets, but before each is the only one I ever use. It's probably the only one you'll ever need to use. You might need to use before all to set up, in a Rails app to do some kind of setting up a test database or something. You have built-in matchers for almost any occasion. I just showed you a very small subset of all the matchers that RSpec gives you. There's just about everything you can want to match on it gives you a matcher for. And invariably, you'll run into some occasions where the built-in matchers it gives you are not sufficiently English-like. You can define your custom matchers. You have another thing for organizing your test, shared examples. If you have a lot of different things that should exhibit the same behavior, you can capture that in shared examples and share those among all of your tests. You have shared context. This is a lot of times useful in a Rails app where you need to set up the same or similar context for a bunch of different tests. Filtering is something you can use if your project gets really large and you have this humongous test suite that starts to take a while to run. Although you should actually be making tests faster, but filtering lets you just only run a certain set of tests. That's also useful if you're there's just it's more useful for filtering out things that are not expected to pass yet because somebody else is working on those at the time. And finally, there's metadata that you can do all kinds of weird stuff with. Anyway, questions?
What's metadata?
Metadata lets you put keyword parameters, basically hash parameters on the end of a describe, or I think you can also add metadata to examples. They're actually used for filtering. For example, you can describe a particular context as being like work in progress, WIP, filter that out. Or focus, you can say only run the things that have focus metadata. So they're basically used for
Use JavaScript as a common one in Rails apps.
Oh, okay. Yes?
What's your opinion of Factory Girl?
I like Factory Girl. I like Factory Girl a lot better than, what was it, Fixtures. Fixtures were what we used before for a number of reasons. Chief among those, you specify what you want to be creating in the test instead of some other file, and it's specific to each test. And you can set up a bunch of defaults and only specify the things that you care about in your factory. factory when you actually use the factory. So yeah, I like factory a lot. Yes.
Where should we go to learn the details? I really want to know what that does exactly.
That's right. I was going to put one last slide in there.
I always have trouble with RSpec.
Relishapp.com/RSpec. So relish like cucumber, pickle relish. It's relish. Relish is this thing that lets people post documentation based on cucumbers. It's called relish. But it's relishapp.com/RSpec.
I kind of have a comment. If anybody's interested in tester development, the project side of Hack Night, thumbs up, check it out. So you'll learn more about this from other people in the group. There's tester development there, so.
It's a good place to see practical applications of it if you don't have a lot of experience doing it yourself.
And you can even drive sometime. We'll let you let people are the same thing. It's not a critique.
The other one, you know, a couple of other places you really want.
All right. Thank you, Jason.